Summary HRNB. Range HRNB. So you can see the probability tables. One second. No, I think you have to reduce the zoom in there. Okay. That should be enough, right? Chart test NB is equal to predict chart NB, comma chart test DF1, comma type is equal to class. So write dot CSV, chart test NB, comma HR NB dot CSV. Okay. So E107 also has support vector machines. Support vector machine. The chart SVM is equal to SVM So it has C classification, radial basis function. Okay. Then chart SVM. We got the same output for summary and print. The chart test SVM is equal to predict the chart SVM comma that is equal to plus. We can write it into CSV file, write.csv. Chart test SVM comma chart SVM dot CSV. Got it? Yeah, it will take time. Because it has to do radial bias function, no? It it's based on geometric this thing. What you call it draws a line on a hyperplane, splitting the data into two parameters. So this is what it will do. It will draw a line between two classes such that two classes will be separated. And then it will draw two support vectors. The dotted lines are support vectors touching the nearest classes. The central line is the maximum margin line. A central line will be drawn that will split the data into two classes, and then two support vectors touching the closest points on both the sides will be drawn. Okay, so on the left side it is negative hyperplane, on the right side it is positive hyperplane. Then it uses vector calculus. It uses vector calculus to find the distance between the predicted value and the nearest classes, and then it will assign to that particular class. So first it will draw a margin line, then it will do support vectors touching the two adjacent values, and then it uses vector calculus. So it uses dot product. Projection of vector A onto vector B. This is called projection. Vector A, this point, starting from the what you call the core axis. This is vector B from core axis. A is projecting onto this, then it becomes a right angled triangle. Right angled triangle, you remember Pythagoras theorem, right? The sum of two adjacent sides equal to the other side. So that it uses that one. So A into B is equal to magnitude of A multiplied by cos theta into magnitude of B, using the trigonometric functions. So this is how it will calculate the dot product of the potential classification of the observation, and accordingly it will calculate. So if vector x into weight vector is positive, then it will be calculated, put it on the positive side. If the weight vector multiplied by x vector is less than C, we put it on the negative side. So this is based on vector arithmetics, where it uses this formula to calculate the vector value, C value, and then accordingly it will use for classification. So this support vectors is based on vector classes. See, projections and all it will use, and then it will find the classification. What the output? Still running. think Canaan is better to be run using the carrot model. So K is equal to 9. So the accuracy is 92.6376 for KNN. But it's not running for you. Huh? Steve, which model is running? SVM. It's run or not running? Okay. So for guys who are not able to run it, we have RStudio Cloud. You can sign up with your Google Mail ID. RStudio Cloud. Wow, that is Posit Cloud now. Yeah, free. Yeah, only cloud, Posit Cloud. Here you can create new space, or you can create our project directly. But how much GB is it giving? So click on new project. You can add new RStudio project, or you can use Jupyter Notebook also for R. You can also use Jupyter Notebook for R. So in industry, you'll be using Jupyter Notebook only for R, both simultaneously running R and Python codes. Which one? Anaconda. See, Jupyter Notebook is part of Anaconda. You can directly use it there, or you can use it from here also. RStudio project. Click on RStudio project. Now we can see the RAM size. Yeah, login successful. Okay. Now the RAM is 1 GB RAM. So you can use it to up to 8 GB RAM. Oh, account limit is 1 GB only. Then it's of no use. Then don't use Posit Cloud. Use Kaggle. Use Kaggle.com. Kaggle will be the best option. In Kaggle.com, code. Kaggle.com code new notebook. So you can use your new notebook, right? In new notebook, by default, it is Python, right? So click on this arrows here, go down, language, change it to R. Change the language to R. Side settings, this arrow will be there, no? Change the language to R. Why it is not changing R? Once you say R, this should change. It changed, huh? I think accelerator also we have to check it as CPU. No, none only, not CPU. Persistence, no persistence. Save version, save. Failed. Actually, the conversion should happen. The moment you change the notebook, okay, click on it, language, R. Why it is not changing? If you say R, it should change to R. Change in the R is open, then it's okay. So you have 12 GB RAM. Yeah. When you say file new notebook, it is opening R only. Right? See, you can now here you have this add data option. Here only you have the add data option. See, add data. Your data sets. Oh no, add data. CSV. Not CSV. Where is the add data? Okay, why keyword search or URL recently viewed data sets we can upload data here. Here is the upload option. Here, you have this upload button. No? Click on the upload button, browse files, desktop, where you have the HR analytics file, na? Hackathon. HR analytics, train file, open. HR analytics. You have to give name. Okay. Then upload files. Test. Open. Okay. Then include duplicates and upload. So you can see here input folder train and test file. Include duplicates and upload, you will get the data. Then run the first cell. Control that shift plus enter. Okay, run the first cell, shift plus enter. After you get the data here, you have to run the first cell. Same Jupyter Notebook command. Then HR train is equal to read.csv, double quotes, go to HR analytics, train file, copy the file path. HR test is equal to read.csv, double quotes, paste the path. See in the folder, you can see both the files, na? Train and test. And you can see once you scroll, you can see the option of copy file path. If you move that to the file, you can see copy file path option. Okay. Now, all you have to do is copy paste the commands from your R file to here. Dot call sums these.na HR train comma decreasing is equal to 2. So in education, it is not reading. So na dot strings is equal to 0, double quotes, comma, double quotes, na. Because it is not reading the missing values, so just adding the additional command so that it can read the missing values. Still, it is not reading the missing values in education. Table HR train dollar education. See, the null values are there, but somehow it is not reading. Now it is reading. Yeah, double quotes without space. Now you can copy paste the commands from there to here. Okay, and it will run very fast because this is your what you call the RAM is very big. See, 4 GB disk, 1 GB, 1.5 GB RAM. Draft session, CPU. All right, right. This also reduced. Accelerator, GPUs. Okay. But this will run faster compared to your systems. So you can add these commands. You can see, right? So in Kaggle, you can run like this. Jupyter Notebook interface for R. So you can copy the complete code of pre-processing into one cell. Here, combined DF. Fill here. Copy all the chi-square test. And models you can copy cell-wise. All hypothesis test I copied in one cell. Then you can also copy the models. Theory you can ignore. Theory you can keep it here only. Here. Logic. Okay. Let's very fast and you get it very fast outputs with all the clear outputs. Take for example, random forest. It ran for you, KNN also? The random forest also runs fast. Okay, so you guys better use Kaggle. Warning message you can ignore. Error messages you should be bothered. Warning messages you can ignore.
So if input file is really big GB, then I can use this one for that.
You can use this one or Collab will be better. Upload the file into your Google Drive, create a folder on your Google Drive, and then because Collab notebooks directory will be there. If you have already created worked on the Google Collab, a Collab notebooks folder will be there. Or you can put it in your Google Drive, create a folder, upload the data in your Google Drive, and then mount your drive. And then once you mount the drive, you give the path of the file from your folder, it will be taken. So that is the easiest way. First, you have to upload the data in your Google Drive. Then open Google Collaboratory. Left side, you will see a folder icon. In that folder icon, you click on it, you will see your Google Drive. First time, click on it, mounting drive, it will give a big password. Copy paste the password in the box and press enter. Only one time. Next time onwards, you click on mount, it automatically mounts. And then you can directly import the data to your collaborator.
But in all they are upload big data.
Big data R has a problem. Paid versions will work, not the free versions.
I was trying to upload some HTTP data.
No, R it will not work. It will work only in Python. Get to Google Collaboratory is best.
So this situation is recorded.
No, recorded. Yeah. So KNN SVM we have built today. Nairbase. 3 models which were built today. In R. Okay. So we will work on time series data. Should we work first on Python or should we continue working in R? Python? We'll go for Python. So you can open a Jupyter notebook. No, no. Conda update double hyphen all. Open the command prompt, conda space update double hyphen all. ALL. You open Anaconda prompt or general prompt? No, you have to open Anaconda prompt. Maybe you didn't did the environment variables. Wait, which one? No, not that one. You have to take service provider data. You have taken some other data. There are multiple data there. Geo service providers data you have to take. Then it is around 6 lakhs or 5 lakhs, not the 92 lakhs. 92 lakhs is very tough. You can't do it on Python also. You have to use Apache Spark, PySpark. Nothing. So that's a very large data. You can't work on. Because see, you have to take the provider's data. No, I'll tell you. So 27th November, I have downloaded. I'll send it to you. 3 GB data.
Yes, sir. So MUP HY R22 T05 version 10 D20 geo.csv, not provider.csv. Geo.csv you have to download. This is smaller file. I think we have downloaded the provider, that's why it is taking a lot of time. We have to do geo.csv. This is the thing which we need. Geo.csv. So this has 2,68,000. Geo.csv, not the provider.csv. Provider.csv is taking a lot of time. So let me show you once. CMS, data.cms. See, physician, this one. No, we need to. All data sets. You have to take Geo, July 27th data. No, November 3rd data is very large. Very large, yeah. That's very large data. So this is the data. Download. Agree. Download files. I think it is the same file, version P05, version 10 only. Yeah, P05 version 10, D20 GeoCSV. This is the file we need. Okay. This is the one. Because the other two data are very large. So that for that we can't use any model also. So use these two data points. Then the parcels, I think I have updated it. Good. Only it's there. Updated data is there. Where? Achha, till September we have. October data we can add. What is that? Three 36, 229. 336, 229. Control X. So this is still October. Yes, I've sent you the data. PJ23 new notebook. So import standard, yeah. Ah. One second, I'll tell you. India car sales is equal to PD dot read underscore CSV. India car sales dot CSV. Corrected? What is your Windows? 11 or 10? Click on Windows icon, settings. Apps. Default apps. You found the apps? Okay. Default apps. Scroll down to browser. So then change H to Google. No, this is to Microsoft recommend. This is the change. Now first we already did it earlier. So you should have closed all anaconda things and then reopened it. Okay. The hell. What's the problem? You can see this or you want me to zoom it a little bit? Huh? It's okay? Car sales dollar. This is monthly car sales of India from April 2011 till October 2022. Okay. So time series data or IoT data has date and time as most critical columns. So in time series data or IoT data, there will be a date column. Either it will be plain date or date with time. We'll work on both types of data. We'll work on date data as well as date with time, hours, minutes, and seconds. The default date format in Python is YYY hyphen or slash hyphen or slash DD HH SS. You can use either hyphen or slash. So in time series data, date is a very, very important column. There are two types of time series. One, univariate time series, where you will have only two variables, date and variable y. Only two columns will be there, like this data which you are seeing here. There is date column and sales column. This is your univariate time series. Multivariate time series along with date, there will be independent variables. There will be independent variables in the data. Along with date, there will be independent variables in data. If you remember bicycle share data, by sharing data, bicycles, we have a date column from which we extracted year, month, season, weekday, whether it is a working day, a holiday, all those things can be extracted from date. So in multivariate time series, you will have variables extracted from date, variables extracted from date like weekday, month, quarter, year, etc., along with both numerical and categorical variables. You will have both numerical and categorical variables. The third type of data is panel data, where date variable, ID variable, a ID variable will be there, and multiple independent and variables along with a dependent variable will be there. So this ID which I'm talking about can be a country name or it can be a company name. It can be country name or a company name. economic data is there. You have year, then you have country, then you have inflation, GDP, population growth, like that you have different variables. And you will take one variable as a dependent variable, and then you do panel data regression. We call it as panel data regression. A different methodology is there. There we use panel data regression with fixed effects, with whatever random effects. There are models which are there, which is mostly used in academic data. Panel data is mostly used in academic data. But in business, univariate time series and multivariate time series are the most important part. By default, date will not be read as date time 64 NS format in Python. Manually change the data type. So automatically it will not read the data as date variable. It will read it as object data. It will read it as object data. We have to manually change it to date variable. Automatically it will not read. Take for example, India car sales dot D types. So it is taking it as object. It is taking it as object. So the first step in time series data is we have to format date. We have to format date variable. For that, we will be using pd dot to underscore date time. Now, this is a very important function which was developed in last 2 versions of Pandas, which is a fully automated function which will read the date and will convert it into the relevant format. So India car sales dot date is equal to pd dot date time or to underscore date time India car sales dot date comma errors is equal to course. Now errors is equal to course means if it is not able to read the date as particular date, it will replace it with NA. It will impute it with NA. If it is unable to format the date, it will replace that value with NA so that we can look at it later and we can impute the date accordingly. Okay. Which one? So errors is equal to course means if the function is unable to convert the format to date type, it will impute it with NA. So sometimes what happens is we'll have mixed data types. Sometimes it will be only date. Sometimes in between you got date with time. So the function cannot handle that one. Either it should be complete date or all should be date with time. Sometimes because of the errors and problems, some are date, some are date time. Now it got confused. So whenever it could not impute that particular date, when it can't convert the particular date, it will impute it with NA, missing value. So that we'll get NAs and then we will impute it later with the corrected with the relevant date. So that is the thing. So date has to be first converted. Now we got the date time, right? You can see here, date time 64 nanoseconds. NS means nanoseconds. Seconds, microseconds, and nanoseconds. Because in sensors,
Generally, it will be Unix timestamp. In sensors, because sensors are all based on Unix, it has unique timestamp, which will be a 19-digit number. That 19-digit number needs to be converted into date time. We have that converter here available. Convert Unix to date time also available here in Python. So sometimes your date which is data gathered to sensors, the date will be a number, 19-digit number, if it is nanoseconds. 16-digit number if it is microseconds. 14-digit number if it is normal seconds. Then we can convert it into the date format. The second step is indexing of date is mandatory in time series. Now, indexing means replacing row numbers with date. Now, if you see the head output, you can see 0, 1, 2, 3 row numbers are there. Then you have the date column. Then you have the variable. We have to index the date. Indexing is also very important in time series. India car sale is equal to India car sales dot date dot index. Now, India car sales dot head. Ooh, what happened? I think we have to set underscore index, not index. Let me just input the data. Set index is not there. What is the value we have to give? Here we have used resample. Set underscore index is there. Dot date set underscore index dot is equal to true. Acha, df dot set underscore index. Sorry. India car sales. Sorry, India car sales is equal to India car sales dot set underscore index. Here we have to give date, comma, drop is equal to true. Sorry. Sometimes India car sales dot set underscore index, date, comma drop is equal to true. After setting the date as index, we'll drop the date column also. So if you see here, row numbers are replaced with date. Row numbers will be replaced with date. This process we call it as index. Formatting the date, converting it into date time format.
That is not the new file name we are talking.
No, in the existing column only, we are changing the data type. Here also, we are just moving the date to index. Because that is the rule for the univariate time series forecasting. So we are just moving the date to the index. India car sales dot plot time is equal to line. You can see the sales plot also. X-axis years, Y-axis values.
And range index of the customer attributes state index.
No, not the variable name. It is data frame name dot set underscore index. Remove the date name. India car sales dot set underscore index. You might have given the variable name also, dot date. Single quotes or double quotes date, comma drop is equal to true. And then just re-import the data again. It might have got corrupted if the earlier command or anything. Just re-import the data and run it again. Corrected? Got the line plot? So time series data is plotted as line plot. X-axis time, Y-axis is the variable. X-axis is always time, Y-axis is variable. You can see here. Now, once you get the data, the first thing is univariate
time series analysis and forecasting. The fundamental assumption is data must be stationary. Data must be stationary. Stationary means constant mean, constant variance, and constant autocorrelation. Simply saying, time does not affect data. So we have to bring to a stage where time no longer has any effect on data for analysis purposes. For analysis purposes, we need to check whether the data is stationary or not. Constant mean, constant variance, constant autocorrelation. Autocorrelation means correlation between the values of y and lagged values of y. So autocorrelation is correlation between y and lagged y. Now, let us say y is this values. Let us say we have these values in y. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Lag 1. Lag 1 of y will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So one step down. One step down. And then the difference between these two will give you the first order differencing. First order discrete differencing. Similarly, this is lag 1. Lag 2 will be, we don't go beyond lag 2. One, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so this we call it as lags. So correlation between y and lag y, we call it as autocorrelation. So in time series data, we use the lagged values of yt minus 1 to predict yt plus 1. That means in univariate time series, we use the historical data, which is yt minus 1, yt minus 2, t minus 3, t minus 4, like that. We go the historical data to predict yt and yt plus 1, t plus 2, t plus 3. So historical data will be used to predict the future data. That we call it as univariate time series forecasting. So the formula is based on the lags. The lags for the previous time period values. This is the autocorrelation. Now, a stationary time series will look like this. So you can see the green one is stationary time series, red one is non-stationary. A perfect pattern within a range, we call it as stationary. If there is unevenness in pattern, narrow and wide, narrow and wide, it becomes a non-stationary time series. So we need to look for pattern. If you want, you can use visualization. See, based on this, does our data looks like a stationary data? Not exactly. We can't make up. We can't make whether the data is stationary or not from the visualizations. So for that purpose, we have a test called augmented Dickey-Fuller test. Augmented Dickey-Fuller test of stationarity. This is a very popular test which we conduct to know whether the data is stationary or not. The null hypothesis is unit root present or data is not stationary. Alternate hypothesis is no unit root present or data is stationary. This is the null and alternate hypothesis. Null is unit root present, data is not stationary. Alternate is no unit root present or data is stationary. P value less than 0.05, we reject the null hypothesis. P value greater than 0.05, we fail to reject null. Based on P values, we will decide what to do, whether to reject null or fail to reject null. Then, if data is found to be non-stationary, then differencing must be done to bring data to stationary. If at all the test says data is not stationary, then we have to do differencing. But differencing, the function is df dot diff. Df dot diff. When you do diff, you have to, the first value will be NA. So you have to omit or drop NA. The first value will be NA. When after doing the differencing, in the data frame, the first value will be NA. So you have to use drop NA. Otherwise, it will say non-numeric data form. So after differencing, please remember, you also need to do drop NA because the first one will be NA. Okay. So this is the process. If the test says not stationary, you have to do differencing. So like I told you initially, there is a library within NumPy called stats models. From statsmodels.tsa.stattools, import AD Fuller. Statsmodels.tsa. TSA means time series analysis library. .stattools, import AD Fuller. AD Fuller, India car sales. The second is your P value.
So the p-value here is reject null. Why? Because that zero, na, May 2020 COVID, we have sales zero. That is affecting our data. If you see our sales, that May data is zero, right? Completely. Because of it, there is some sort of normalizing happening. Otherwise, it is not a what you call stationary time series. Because of that one value being zero, COVID shutdown, lockdown, and all, we had a issue. That's why it's reading the data as stationary data. So we can't do anything. We'll go with the stationary data itself. If it is not stationary, then what we have to do is we have to do differencing. I will show the differencing procedure also. So India car sales diff is equal to India car sales dot diff. Okay. Then India car sales diff is equal to India car sales diff dot drop NA. First observation you have to drop. India car sales diff dot plot kind is equal to line. You can see the differential data. This is the differential data, right? So if you do differencing, if the hypothesis test says the data is not stationary, we need to do differencing. After doing differencing, the first observation will be NA, so we have to drop NA. Then we can do the plot and analysis further. But in this case, data is stationary, so no need of differencing.
What is the difference in value? Which value was?
Of car sales. So we take the difference, na? So this is how. Okay. This is the differencing procedure. So if you look at our diff values, okay. So lag one down. By differencing, we are taking the first lag down. This is lag one differencing. Lag two means you paste the data here and then first two observations will be NA and then you calculate the differencing. So we don't go beyond 2 lags. First order discrete differencing is this. First order discrete difference is this. You paste the data one step down and then you calculate the difference. Got it? So that is what this diff function will do. Okay.
Not like that because
And that's what you have to do, drop NA. So that's what I did, not drop NA. Diff dot drop NA, give the right data frame name. That NA has to be dropped, otherwise it will give you non-numeric data found. Do one thing, import the data, run on all the cells. Because in time series, once the data gets corrupted, you have to re-import the data and do it again. But before that, correct the mistake. So remember in time series, because we will be doing data changes, major changes on data. If at all any error comes, correct the error and then go back and run all the cells. After correcting the error only, don't do it before the error, because again the error will repeat. So once you correct the error, go back and run all the cells, because we are doing that major changes on only one variable, right? That's the problem. Multivariate will not have that issue, but in univariate, this is the problem. Clear? Okay. So this is the process of differencing, which is done to understand, to bring the data to stationary. If at all the data is not stationary. It's already 4 o'clock. We'll take a tea break. Yeah, and then we'll come back. Continue.
This is stationary.
Our data is original data is stationary. This is stationary. You want to check, you can check. So India car sales diff is there, na? AD Fuller, India car sales diff. P value is less than 0.05 stationary. So after differencing, it will become stationary.
What is the statistic behind this? What is the statistics behind this?
AD Fuller uses a formula. So decay Fullerton, this is the formula. It's like regression only. Beta t plus alpha yt minus 1 plus epsilon delta yt minus 1 plus et. This is the, it's like regression only. So it's like regression formula only. See, this is the formula it uses. It is a regression formula only, and then based on that test, it will tell you whether it is stationary or not. So it's based on a regression formula only. This is the formula. Or breaking into components. Breaking in time series into components. There are 4 components. trend. There is uptrend, downtrend, neutral, or horizontal. So the first component is trend component. Upward trend, downward trend, horizontal trend. Second, seasonality. Based on 4 seasons. Based on 4 seasons. Seasonality is short term because in a year only we have these 4 seasons, right? Short term because less than year. Anything which is less than year, we call it as short term. The third one, which we generally don't see in the graphs, is cyclicality based on business cycles, typically long term, 8 to 12 years. Economic cycles or business cycles is also very important in time series analysis. If you are looking at cyclicality, a typical business cycle will have these phases. Expansion, peak, recession, depression, trough, recovery, peak, and recession. Now we are in recession right now, where we are going down. If things get worse, we might hit depression next year. So once you have depression, you will hit a low point, and then from there we need to recover, which have we seen in 2008 financial crisis. We have seen it in 2012 Greek debt crisis. We have seen it during COVID, how our economies have stalled and all those things. So the cycles will repeat. Nothing lasts forever. There is always a growth, comeback, and everything will bring normal. So cyclicality is a long-term trend. The fourth one is random, also called as residual or error. Actual versus predicted. So in a time series, we generally have these 4 components. But since cyclicality is a long-term component, it is not plotted on the graph. We just use it in formulations. In formulas, we use it, but we don't plot it in the graph. 2 statisticians, Hall and Winters, method of decomposition. 2 statisticians, Hall and Winters, they developed this method of decomposition. First, additive model, which they suggested for non-seasonal data. It is YT is equal to trend T plus ST plus CT plus random T. They also suggested multiplicative model for seasonal data. YT is equal to trend T multiplied by seasonality T multiplied by cyclicality T multiplied by residual T. So in most of this, we use this Holt-Winters method of decomposition, which is very popular method of decomposition the time series to understand the seasonal pattern, to understand the trend, what is the trend in the data, and what is the error or random in your data. From stats models dot TSA dot seasonal import seasonal decompose. Seasonal decompose India car sales dot plot. It is repeating 2 times the plot, but it is the same plot. Now you can see the trend is slightly upward. Car sales are going up back. Initially it fell last year. Now in the beginning of the year also it was little bit low, but now it is recovering and going upward trend. Okay. Then seasonal pattern seems to be there because you can see a fixed pattern repeating every time. It looks like a seasonal pattern because a pattern is repeating over year every year, fixed pattern, right? And then you can see residual or random. All of them are closer to line except some points where we had some distortion in data. Okay. Now, time series, univariate time series forecasting. Hello. Yes. Yeah. No, no, right now I'm not interested. So the whole point is to do forecast. Predict for next 36 months or 3 years. We need to forecast. We need to predict. One of the important tasks in business is predict for the future. You should always have some sort of prediction, some sort of forward view for next 3 months, 6 months, 9 months, or 1 year. A prediction or a forecast must be there so that you can plan accordingly. So that is the purpose of univariate time series forecasting. There are many methods available in univariate time series forecasting, but the most used model is ARIMA. ARIMA is the most used model, PDQ. Auto regressive integrated moving average. The full form of ARIMA is auto regressive integrated moving average. ARIMA, AR is autoregressive, I is integrated, MA is moving average, and you need to have three lags, PDQ. PDQ are the lags which lie between 0 to 5. For P and Q, it is 0 to 5. For differencing, it is 0 to 2. For PQ, it is 0 to 5. For D, it is only 0 to 2 lags. There is also called seasonal ARIMA. Seasonal ARIMA, because in Python by default, seasonal ARIMA model is built. We call it as SARIMAX. SARIMAX, which has P, D, Q, and then you will have additional parameters P, D, Q. These are seasonal parameters and the frequency. If the data is having seasonality, then seasonal ARIMA model is built. If the data does not have seasonality, then SARIMA with only PDQ will be built. Only this model will be built, which is nothing but ARIMA PDQ. If the data has seasonality, then SARIMAX, you will get PDQ and another capital PDQ and then the frequency of seasonality. Whether it is 12-month seasonality, 4-month seasonality, or 3-month seasonality, you will get it. If it is non-seasonal data, you will get SARIMAX PDQ only. Only one set of parameters. That means it is an ARIMA model, non-seasonal model, PDQ. So, two models are there. One plain ARIMA model, one seasonal ARIMA model for seasonal data. PDQ are the lags that need to be given to the model based on the data pattern. Based on the data pattern, these PDQ values are to be given. For PQ, the values range from 0 to 5. For I, it ranges from 0 to 2. For P and Q, the values will range from 0 to 5. 0, 1, 2, 3, 4, 5. But for differentiation, it is only 0 to 2. 0 differentiation, first order differentiation, second order differentiation, beyond which we can't go. I is integrated. Integrated is nothing but differencing. AR is autoregressive, I is integrated, MA is moving average. AR P is linear relationship between values of Y and lagged values of Y. AR is the linear relationship between Y and lagged values of Y. You might heard the same statement in multiple linear regression, right? Same thing. ARIMA is nothing but it is a system of two equations, ER equation and MA equation. The I, which is integrated, is based on differencing to be done to bring data to stationarity. Then MAQ is linear relationship between errors or residuals and lagged errors or residuals. So AR or AR is linear relationship between lagged values of y and lagged values of y. MA is linear relationship between errors and lagged values of error. So the equation looks like this. The forecasting equation of ARIMA is this. Intercept plus AR terms, lagged values of y, linear equation, minus MA terms, lagged values of errors. AR terms are positive, MA terms are negative. See here, T minus 1, T minus 2, T minus 3, you use the historical data to predict. Here, historical errors, minus theta et minus 1 to theta et minus q. Epsilon yt minus 1 till epsilon yt minus p. So two equations will be there. Both of them are linear regression equations only. But one is for positive for values. The second is negative for errors. So AR is positive terms and MA is negative terms. So ARIMA is a multiple linear regression with two equations. One, the AR equation, the other is MA equation. One is the equation for values, the other is equation for errors. Autoregressive integrated moving average. It's a very good model in forecasting. It has been developed long back and it is widely used in industry to forecast. In FMCG, consumer durables, auto sales, these models are widely used for predicting. And ARIMA works well in short-term prediction as well as in long-term prediction. There are various extended models of ARIMA. Like one model developed, which is very popular, is Prophet, which is developed by Facebook. Facebook has developed a model called Prophet. The underlying model is ARIMA only. They use that model to predict hourly traffic onto their various websites. They want to predict how many users will be active on their web pages, Facebook page, updates, and also they need to predict the number of users at a point of time. Hourly predictions they want to do. They want to do daily predictions. So for this purpose, they developed a model called Prophet. The underlying model is ARIMA only. They included daily seasonality, hourly seasonality, and they made changes to the equation, and they developed a very good model which has very good performance compared to ARIMA. So AR, the P lag can be identified using partial autocorrelation plot, also called as PACF plot. MA Q parameter lag can be identified using autocorrelation plot, also called as ACF plot. Two plots can be drawn for identifying the lag values of P and Q. What should be the value of P and Q can be identified using these two plots. And D value based on the differencing what we are doing. Whether we did differencing, we can put. If we don't do differencing, 0 will be D value. So what we have to do is to identify the AR P and the P lag and the Q lag, we need to have ACF plot and PACF plots to identify. These two plots will help us to identify the parameter. So in ARIMA model, you have to compulsorily give the PDQ values. Without giving those values, you cannot build a model. The values must be given for PDQ. To identify the values of P, Q, DQ, we need to use ACF plot and PACF plot, and also the differentiation that we have done on the data. Okay. From stats models dot TSA dot seasonal dot dot graphics TSA dot seasonal dot one second, stats models dot graphics dot TSA plots. Import plot underscore ACF, comma, plot underscore PACF. Stats models dot graphics dot TSA plots. Import plot underscore ACF and plot underscore PACF. Plot underscore ACF India car sales. Now you get a plot like this. You have the lags, and then you can see the values. For interpreting these plots, you need to have a little bit understanding. So generally, we don't need to look at this spike at 0. Okay, then you look at the pattern at which lag the pattern is drastically changing. Here, at 1 lag, it is changing a lot. See, it is below the threshold line. It is below the dotted blue line, 1 lag. See here, lag 1. There is a huge change. So here the value will be lag 1. So when you're looking at ACF and PACF plot, from the 0 lag, where there is a drastic change, at which lag it is going to the threshold line. Now the threshold will be either represented like dotted line, or in case of Python, it will be represented by shaded lines. Shaded, right? So if you look at it, there is a big difference from 0 lag to, if you look at the pattern change, I think somewhere at lag 3 or 4, 3, it is touching towards the blue shade. Right. So we can assume it can be 3. Similarly, plot underscore PACF, India car sales, same pattern analysis we can do. At which point it is going towards the blue area. I think here it is changing around lag 2. Right? Lag 2 itself, it is going to the negative area, blue shaded area. Right? So reading from these plots is little bit difficult. Reading the lag values from the plot is very, very difficult. And we often make mistakes. So to avoid this problem, we have a function called auto ARIMA that tries all combination of values from 0, 0, 0 till 5, 2, 5. Auto ARIMA is a function which is developed that simply tries all combinations right from 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0. Like that, it will try all the combinations till 5 to 5. It identifies the combination of lag values that has the least AIC. AIC is Akaik's information criterion. It is just like an R square. So the combination of lags that have the least AIC will be the final model. It starts from 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, then 1, 1, 0, 1, 1, 1, then 1, 1, 2, 1, 2, 1, 2, 2, 1. Like that, it will try all the combinations and it will find the combination of the lags that has the least AIC. Simply, it builds models with all these lags in the backend and it gives you the model that has the least AIC. That is what it will do. Now, to use this auto ARIMA, you need to install pip install. I have already installed, so I'm putting it in exclamation. You need to type it directly. Pip install PMD ARIMA. Just install. Because I've already installed, so I'm putting it as a hashtag. You have to type directly. From PMD ARIMA dot ARIMA import auto underscore ARIMA. Just install PMD ARIMA. Okay. It installed? Yes. Then import the function from pmd.arima import auto arima. Okay. So it tries all. Now let us see what is the output we got. Car sales ARIMA dot summary. So it has built a non-seasonal model, which is 113. PDQ values is 113. Then you have to check AIC. It's a comparative metric. AIC is 3295.01. This is the lowest AIC it finds. All the combination, the lowest AIC is for 113 model. This is the. Then we need to check the P values. The P values must be less 0.05. So if you scroll down and see for the lags, see all the P values except MA lag 1, it is all less than 0.05. Except the MA lag 1, rest of all are less than 0.05, the probability values. So this is what first we need to look at the output.
Sir, I'm getting one error when installing this function.
Okay, what error you are getting?
Cannot import name underscore version underscore from stats model dot version.
Okay. You have to update your this thing. Conda update all you have to do. Same error, huh? So just open the Anaconda prompt and update Conda update double hyphen all. So Conda update double hyphen all. You type this, no? First, just open Anaconda prompt and update your Anaconda first. No module name could not install packages due to OS error. Access is denied. Logic win PID. Consider using the hyphen U or check the permissions. You also have to do update libraries once. Anaconda prompt. Conda update double hyphen all. Once you get the list of packages, give small y and press enter. It will proceed yes or no will come. Give small y and press enter. Okay. So just update the libraries, you should be able to install this thing. Okay. So one other metric you have to look at is the lung box test. Residuals for model fit. So the null hypothesis for this is model does not show lack of fit, or in simple terms, the model is fine. Alternate hypothesis is the model does show lack of fit. Model show lack of fit. Null hypothesis is model does not show lack of fit. Alternate hypothesis, model show lack of fit. Here, the p-value must be, this is one place where the p-value must be greater than 0.05 for failing to reject null. Most of the times we look at p-value, we always say less than 0.5 and reject null. In this test, the p-value must be greater than 0.5 and we should have failed to reject null. That means we have to accept the null. What is the null here? The null is, the model is fine. The model does not show lack of fit. So if you look at the value here, the probability Q. So since probability Q 0.595 is greater than 0.05, we fail to reject null. So our model is just fine. Model is just fine. The lung box test of residuals. Normality, fit of normality and all will be done, and then it will, the probability Q must be greater than 0.9, 0.05. No, p-value has different references. Here, see, we use the word p-value. Here it is probability of Z distribution. In ANOVA, we get p-value, PR greater than F. In chi-square, you also get p-value, which is based on chi-square distributions. Similarly, here, lung box test uses probability Q. This what you call based on this lung box Q, it calculates this one. So the p-value I'm using it, but here the right term if you want to use is probability Q. Okay. I use the word p-value, but when you see the outputs is different, right? In R we get PR greater than F for ANOVA, chi-square will get a PR value. Here we are getting p-values as PRZ. So they are all nothing but p-values.
They are also p-value greater than 0.05.
Yes. Failed reject null. It is same. Logic is same. Less than 0.05 reject null. Greater than 0.05 failed reject null. Probability values. Any probability values, we follow the same 95% confidence level. You can also see the diagnostic plots. So diagnostic plots, you can see here, normal quantile plots. In regression, I told you in R, most of the observations should be closer to the line. Here we have most of them closer to the red line, right? If you remember, I told you about the QQ plots. So this is going towards lower end. So this is negative skewness. I think I have not shown you those plots, how to read it. U24. QQ plots, when you're reading, they are very important in QQ plots reading. See here. Reading the QQ plots is very interesting thing. They are asking these days in interviews also. Quantile plots. Okay. Why is it not coming?
Yes.
Yeah, markdown cell only, no? It has to be markdown cell only. No problem. But this is the plotting thing, QQ plot. See here, normal means most of them will be closer. Positive skewness means on the top. Negative skewness means you will see on the downside. Negative skewness means downside. Positive skewness in upside. Now, if you look at our quantile plots, you have where? Down or up? Down. So if I see the output of the ARIMA, the skewness is negative. So the QQ plots will help you to do this. Let me just get this graph. I'll paste it down. Where is the plot? Yes. Yeah. See, this is the quantile plots. And you can see here negative skewness. The plots downwards negative skewness. So our data is negatively skewed. Okay. Now the ultimate agenda is to forecast. Forecast for next, let us say 12 months. I want to forecast for next 12 months. Car sales forecast is equal to car sales ARIMA dot predict n underscore period is equal to 12. Car sales forecast. So this is the point forecast we are getting for next 12 months. It imported PMD ARIMA, running the updater. No problem. PLT dot plot. India card sales. PLT dot plot. Car sales forecast. PLT dot show. Did you get any plot? No, it's not coming. Okay, I think we have to use specific code. So it is just coming like a small orange line pattern. If you want, you can do it connected to the exact line. So you can see a small orange pattern coming at the end because we're just predicting for 12 months. So we got a small line like that.
Sir, it is showing again like same import error. Cannot import name np underscore ld underscore 123 from stats models dot compact dot numpy.
So what you can do is open Anaconda prompt
Okay.
and then do this Anaconda PMD ARIMA is there, no? So this one, Conda install -C, Conda -force P and ARIMA. You have to do it in Anaconda prompt, not in your Jupyter notebook. In the Anaconda folder, you will see Anaconda prompt, right?
Yes, sir.
Then you do this Conda install -C, Conda force. Just type in Google Anaconda PMD ARIMA. You'll get the link.
So same error, sir, again.
Again, huh?
Yeah.
What browser you are using? Edge or Google Chrome?
Edge.
No, change the browser to Google Chrome.
Okay.
Default browser, sometimes Edge does not compatible. Use Google Chrome, no, please. Once change the default browser to Google Chrome.
Okay.
Index access dot index -1. Frequency is equal to M.
also you are doing the same thing now. India passes in the side. So, first data. So now, index underscore PD dot data underscore range. India passes dot index. Minus one, comma. Period is equal to 12. Comma frequency is equal to n. Okay. I think you might have run the command multiple times, so index might have gone. So, you have to redo the index again.
Yes, so now it works.
It's working?
Yes, sir.
Okay. Up. Here?
Sir, can you scroll up a little bit where the function importing after that?
Here.
Yes. Yes, so we can scroll down.
Previous time periods. That is what univariate time series does. Yes, so what will be the future states? So we are getting actual values. So they are closer almost. In univariate, multivariate, we'll use regression models. Decision tree, random forest, we take the different. Important variable, same process, how we do regression, na? In multivariate time series analysis, same process. We extract variables from date, month, year, quarter, and all those things. And then we do the same process like how we do in regression modeling. Same process. Can I scroll down?
Yes, sir.
And then run out the cells. What is other coming, any change in the other, say that.
We can scroll down.
One second. So show me the other one. Structural issue. So go back to status quo and see what is the other solution. Indexing error is the problem. No, not zero elements. It has to have been error in the 10 and 12 mismatch is happening. Index is losing two values. Please find here that. The change is to minutes to 10. No. Then okay, no problem. Very good. How is the business? We have added four. This is done. Forecast is done. So this is the thing. PLT.plot. Same thing, what she said here, you install it on the phone? Install it. That you have not done, huh? No, do it in Anaconda phone. Anaconda python. Anaconda pyramid, PMD ARIMA. That is Google Anaconda PMD ARIMA. PMD ARIMA. First thing. You open Anaconda form. In the Anaconda folder, in this Anaconda form. You go down, you will take on go to Anaconda folder, click on the windows, right then. Anaconda folder, and suppose this. Anaconda from. From doors. That one. If you give you base and then your name and file, then you get the thing. Or go to second option. Now paste it. Enter. Wait till the package. And then say yes, right, small right.
The index is the index of chip. Cannot assign to functions or 58. 56.
You also got. Oh, now that. Okay, we don't need to worry.
Model pandas as one.
Date underscore range, not date underscore range. Date underscore range.
No, we don't have.
What?
Maybe in that way. But if you tell me, then again I was.
Which one the placement thing? They will meet you later. They have come to meet the new batches which have started.
Actually, we got message.
Uday, yeah.
You need to compulsory.
The Bombay guys have come, na?
The 24th batch will get finished early.
No. 24 batch will end maybe in April. There is some major problem with some guys. Language issues are there, soft skills. So 6 people, they are not able to understand the English, first of all. Second thing, their typing is also, they're committing mistakes, the spelling mistakes. So a word like replace also, they are not able to type it correctly. And because they were from background of Telugu medium and all, something like that. So they have that issues. So we are going slow.
I thought like you are going very busy, that's why taking.
No, we are going that slow.
If you want to join,
Huh? Yeah. You can join, but same models. Today we started with ML. So that we are in the 4th week now. 1 month is over. For you guys, I have started ML in 2nd week or something like that only. For them, it is almost after 1 month I have started. So that too now they are still struggling. So they are not able to comprehend. Excel, very poor Excel skills. Because I think half of them, people who have job experience, they're doing it. The batch has, half of them are freshers. That is the problem. No, SQL and all are done. 1 month SQL, Tableau, Power BI, all are done. Excel is also done. But they were not able to understand. Then I told them, why you should have told them the same thing. The problem was half of the batch wants to go it faster. They want to complete the course fast, particularly WorkX guys. They want to complete it faster, get into placements faster, and change job faster. These guys from the freshers background, they are learning very slow. So because of them, we are not going faster. We have to drag and go very slowly, step by step, mistakes, corrections, and all. So language skills are very bad, both written as well as speaking. Oral skills are bad. So that's why I told them they have to put under soft skills and all. So they're discussing. So what to do with them.
Usually this pressure and work experience, they have to supplement. So they told us.
You see, in this batch, they combine them into one. The problem is experienced guys want faster. They want to move into jobs faster, and their comprehending skills also very fast because they go through trainings and all, they have experience. But these guys, they can't catch up. That is the problem. So I have to look at these guys because half of the batch is freshers only. So they are something like, type the function name and use the tables, they're not doing. They're typing the function and creating spelling mistakes and waiting for me to say error. When I go and see the error, median D is missing. So mean MEN is typing instead of MEAN. So that sort of errors only wasting the time. So I told them first 3 letters and tab. That way you can avoid those mistakes and all. But still they are not adjusted to that format. 3 letters tab, you have to use if you are not good in typing the things and all. Some people have laptop issues. I told them, get a keyboard. If key is not working, what can we do? See, bigger batch will have different problems. That's the issue. Which one? After doing the Conda install also. Warning, error or warning? Avatleda? Repeat. Install and uninstall. Uninstall and install, they are saying. NumPy. Wherever is NumPy, na? NumPy.py. So what we do is after going home, uninstall, exclamation pip uninstall NumPy. And then pip install NumPy, exclamation pip install. In this of prompt, your choice. No, if you're doing in prompt, it is Conda. If you're doing in this pip. Exclamation. First, you have to give the exclamation mark. Pip uninstall NumPy. After uninstalling everything, again pip install NumPy. This is from Jupyter Notebook. Okay. If you are doing in Anaconda prompt, Conda uninstall NumPy. Conda install NumPy. C cap, small letter. Yeah, do it at home because it will take time. NumPy is very large package, na? It will take time. Tomorrow 9 to 1, na? 9 to 1 or 10 to 2 is okay with me, no problem. 9 to 1 would be better, na?
But online you like that.
Tomorrow is online only. Yes, tomorrow I have IMT that class is from evening 4 o'clock till 8 o'clock. Backlog sessions are there. So only slot is 4 o'clock in the evening till 8 o'clock. That is behind airport, the campus. Behind the airport, you have to go in that villages. It is between that backside ORR Vijayawada highway side, there's something. From here, it is very near. From Gachibowli, it hardly takes from ORR 40 minutes. But from my house, we have to go to Shamshabad, cross the Shamshabad toll booth. Left, we have to go in villages. All roads will be very bad, and we have to go. IMT Hyderabad, but IMT Ghaziabad campus. Web analytics, text analytics. Only last 3 sessions, but somehow they want me to meet personally urgently. Till now, I'm doing it online. They said insisted on offline class. So I have to go. What to do? Otherwise, I would have done online class 2 to 4 or 2 to 5. Happily done. But anyway, last sessions, no? So bits is not going on. Bits batch is over. The new batch, I think I'm not sure. They have not new batch might have started. Maybe they recruited some faculty internally. Maybe some internal faculty is taking. Otherwise, they would have given me in December only. Generally, they come to me when the existing faculty doesn't work. That is the problem with BITS guys. So they try with their internal faculty. If that students complain that I'm not understanding this and all comes, then they suddenly call me saying that please take it. And then it becomes a weird timing. Either it becomes evening Saturday, Sunday 6 to 8, or Sunday morning 8 to 10. Like that they give. Because already timetables will be done for based on other classes, right? And this becomes a problematic thing. So I'm hoping they will not call me because every time it is becoming like that only. I have to handle this sessions with lot of complaints saying that, we are not able to understand, or the faculty was too theoretical, all these problems. So generally what I'll do is yeah, Supriya, I'm ending the session. Huh?